Yes, hi folks. And today we just talk about reduction formulae. Okay, so these reduction formulae are of what kind? Let me just discuss about them. Okay, or define them. The reduction formula we mean that a formula which is which is used repeatedly to integrate an integral or an integrand, in such a way which is not easily integrable, but with the help of this reduction formula, it is integrable easily. Or now integral. So what is reduction formula? Reduction formula is a linear relationship between or algebraic relationship between two integrals, okay, in which the integral which is being integrated is reduced into lower degrees, okay, and to obtain another integral of the same type or similar type, but of lower degree. Okay, that is a reduction formula. Now this reduction formula is used repeatedly or successively in a repeated manner. Okay, this formula, which is used repeatedly, is known as reduction formula. Now, in this case, reduction, why reduction? Reduced. So, it means the integral which is being integrated is reduced into a lower degree integrals. So that is known as reduction formula. These reduction formula are mostly of very important formulae which are used only when the integral is not easily integrable. These formulae are used just to integrate some non-integrable functions which are not easily integrated, but with the help of reduction formula, we can reduce it successively to till it is being integrated finally. This is known as integration, so reduction formula. Now, this successive use of reduction formula is mostly obtained by using, generally obtained by using integration method of bypass. So bypass method is used to obtain this kind of reduction formula. Okay, let me discuss what is that we define then and what the reduction formula today I am talking about. So this is a series of lectures which I am going to discuss about what are the total reduction formulae, different kinds for sin x, cos x, tan x, cot x. Okay, then EAX and something. Okay, so continuing reduction formula we will discuss about. So about from 43rd to about 50 to 52, 53 lectures are there. Okay, so these lectures are about 10 or 11 lectures are there. Okay, so or at least 10 that I'm going to discuss about. These lectures are very much devoted to only reduction formula. These are very important in integral calculus. In integral calculus, the reduction formula being that an algebraic relationship between two integrals. One integral or one integrand is in which we are going to integrate this integrand into uh, another integral, okay, in which integrand is of lower degree than that of the original one. Okay, so this is what a linear relationship in these two formulas. They are of similar type, but degrees may be different. Okay? I mean, the integral the integrand which we are going to integrate is of higher degree than the integral which is obtained. That integrand is of lower degree. Okay, so this is what integral successive reduction formula is known as. Okay, so this successive repetition of use of this formula repeatedly is known as successive integration, or this reduction formula is known as successive successive repetition of formula in the form of reduction formula, because it is going to reduce the degrees of the integral given. This is known as reduction formula. Is going to reduce the okay, so let me define it. Okay, in integral calculus, let me talk about it. In integral calculus, the reduction formula, the reduction formula we mean by a connection or an algebraic relationship, or an algebraic relationship between the integrals in which one integral is reduced to another integral integral of the similar type but of lower degree This is known as reduction form, reduced form, not reduction. We have reduced the degree of the integral which we are going to integrate. This is known as but of lower degree. Then, but of lower degree, we have just one integral is reduced to another integral of the same type but of lower degree. This form of interconnected, or let me talk about this form of formula which is used successively in a repeated manner is known as a reduction formula. These reduction formulae or formulas are the reduction formulae which we are going to discuss in this chapter. Okay, is known as reduction formula, which is in which the integral which is not easily integrable by other methods but by an algebraic relation or connection between the original integral and the obtained integral in which obtained integrand is of lower degree in comparison to the original one. Okay. This is known as this formula is used repeatedly or successively, similar to the original one. Okay. This is what now in this case to obtain, let me write here, to obtain a reduction formula, Okay, reduction formula. Generally, the method of The method of integration used is bypass method. Bypass method. Okay, so usually we use bypass method to get a reduction of formula or get a reduced formula. Okay, to obtain a reduction formula, generally the method of integration used is bypass method. It is bypass method. Right? This is what the reduction formula. This obtain the reduction formula is used repeatedly till the final integral is obtained which cannot be further reduced, which cannot be further reduced to lower powers. Here is the last lowest power, I mean, to lower power or degree. This is the repetition of reduction formula which we are going to use. Now let me take the reduction formula successfully for first. Let me take for sine and cos. The reduction formula for sine and cos. Let me talk about. And these formulae will be used successively for other integrals. I'll note down those formulae so that they can be repeatedly used easily, okay, without any difficulty. Now let me talk about this. So first formula, let me talk about integration of sine of integration sine nx into dx. So reduction formula for sine nx, and n is any general degree, okay, of n sine. Now what we have to do to integrate this, we have to divide. One has to divide it into two parts, that is sine nx is equal to sine n minus 1 x into sine s, okay, into two parts, so that one uh, function, there are two functions. One function can be taken as first function, and other can be taken as first and other as second for bypass method, for integration by bypass method. This is one thing. Okay, so now let me integrate this. And what is to be taken as first function, second function? Let me take this as the first function for differentiation, and sine x as second function for integration. Okay, so therefore, sine of integration sine of nx into dx is equal to sine of n minus 1 into x into sine of x into dx. Okay, now integrating it using bypass method. by parts method taking sin x as the second function, sin x as the second function, and sin raised to power n minus 1 x as the first function. It is the first function. What will be the integration? First function as it is. Therefore, this is equal to integration of this whole is equal to first function sin raised to power n minus 1 x as it is into integration of sin x into dx minus sin ddx of sin raised to power n minus 1 x into integration of sin x into dx whole dx. This is the basic formula of by parts method. Let me integrate this. This sin x is minus cos x. It will be minus sin n minus 1 x into cos x minus sin differentiation. It will be n minus 1 into d into n minus 1 into sin of n minus 2 into x. Why? Because we, in case of differentiation, we take the power in multiplication, n minus 1 is taken before, and 1 power is lessened, n minus 1 minus 1, it means n minus 2 power is left over. But sin x is not x, so it is to be again differentiated. Its differentiation will be sin cos x. Its differentiation will be cos x. This is differentiation of sin raised to power n minus 1 x into this minus cos x into dx. Differentiation of sin x is, integration of sin x is minus cos x. What does it mean? This means minus sin n minus 1 x into cos x minus sin, this is minus 1 plus here, n minus 1 sum of integration. This is nothing but sin n minus 2 into x into cos square x into dx. Now let me further solve it. Let me write it here. Therefore, what it will be? First is minus sin, minus, let me first write cos x or cos x into sin raised to power n minus 1 into x. This is plus sin n minus 1 sum of integration. If I convert this sin n minus 2x into cos square x is 1 minus sin square x into dx. Now further resolving of this cos x, sin of n minus 1 into x. Okay, this is now plus sin n minus 1. Now sin n minus 2 x into dx equals into 1. That means no change in sin x. The second part will be minus sin. It will be minus sin of integral. Sorry, n minus 1 is also there. This is n minus 1 into sum of integration. Now it will be sin nx into dx. Why? Because 2 power and this minus 2 power. The sign when base is same, powers are added. So sin x whole power will be n minus 1, n minus 2 plus 2. Minus 2 plus 2 cancel out only sin nx. Now this is a similar function, okay, which we started integration. Okay, integrating. So which we started integrating. The same function is obtained. Taking this function, this side, it will be what? It will be only n because this is 1 plus n minus 1. So this will become plus here, but this is sum of integration. Sin nx into dx is equal to this value minus cos x into sin of n minus 1 x plus sin, this is n minus 1, this value sin whole power n minus 2 x into dx. Okay, now let me divide by what is the remainder value here. Okay, so the addition of this will be minus 1 plus 1 cancelled out, only n, so dividing by n, we get therefore sin nx into dx is equal to minus 1 upon n. Let me write first cos x into sin e power n minus 1 into x divided by n plus n minus 1 upon n sum of integration whole power n minus 2x into dx. This is what we have obtained. Okay, so now this is the first formula which we have obtained for sine. Now second, what is cos nx? Similarly, if I write here cos nx, so cos nx and cos raised power nx into dx will be, we will write it in the same way as cos n minus 1x into cos x, but integration of cos x is sin x. The first step will be positive. Here it will be plus sign because minus sign by there, that minus sign will again become negative, and then okay, and because here sin x cos x will be differentiated as well. In case of differentiation, that will be negative. The same process will obtain. This will be equal to cos nx equal to, similarly we can write, and similarly this is the reduction formula. Similarly, reduction formula, this is the reduction formula for sin x, for formula, reduction formula for sin of integration cos of nx into dx is equal to, now it will be sin x, positive value, sin x into cos of n minus 1 into x upon n plus sin n minus 1 upon n sin of integration into cos whole power n minus 2 into x into dx. Now here it will be positive only. In case of sin it is negative. This is the only difference, otherwise the same value will be obtained. This is n minus 2 power lesser than, and this multiplication is the same, n minus 1 upon n. Okay, in case of cos, let me prove this. So these are the two formulae which we have to obtain. So let me take the formula for this. This is the answer by writing similarly, but let me extract this or calculate this in the same way so that the formula can be obtained. Finally, what is the formula for this? So we have obtained sine formula. Let me write it here. Sine of integration sine power nx into dx is equal to minus cos x into sine raised power n minus 1 into x divided by n plus n minus 1 upon n sine of integration into sine n minus 2x into dx. This is the first formula for sine. Sine for this is reduction formula for sine. This is reduction formula. Now let me find out for cos. Second, I think this is second question also. Question number second for cos of nx into dx. Again we have to, this is the formula, but let me obtain this similarly. So let me reduce this into two parts. It can be reduced into two parts as cos of n minus 1x into cos x, no change, into dx. I'm taking again this as the second function and this as the first function, second function. So integrating it by parts, integrating it by using BP method or by parts method. By parts method, we get, what do we get here? Now cos n minus 1 x as it is, sine of integration, this is cos x into dx minus sine of integration ddx of cos of n minus 1 x into integration of cos x into dx whole dx. What is obtained here? This is sin x, because integration of cos x is positive sin x. It will be plus sin x here. Sin x into cos of n minus 1 into x minus sin. Now it will be negative sign. Why negative? Because differentiation of cos x is minus sin x. Okay, but before that we will get here n minus 1. Okay, sine of integration versus cos of n minus 2 into x. Then minus sin x will be there. This minus sign will be positive. But here it is sin x positive. Integration of cos x is sin x. But differentiation will be First, n minus 1 power will come before 1 power will be less than this, so it will be cos n minus 2x. Again, cos x is not x, so differentiate again by chain rule, by function of the function method. So cos x is differentiated with minus sin x. Integration of cos x is sin x whole integration whole dx. Okay, so what finally we obtain, let me again write it as sin x cos of n minus 1 into x minus, this will be plus sign here, n minus 1 sin of integration into cos n minus 2 into x. It will be sin square x. Sin square x is written as 1 minus cos square x into dx, the same process. Now from this we will get 1 cos n minus, but this minus will be n raised power n. So same value will be obtained. This is sin x cos of n minus 1 x plus n minus 1 sin of integration into cos n minus 2x into dx into 1 into this. Second will be minus sin n minus 1 sin of integration cos whole power n only. Why? For this 2 power and minus sign minus 1 plus minus sign and cos n minus 2 into cos is square, again n minus 2 plus 2 is n only power that is there. Therefore we have obtained this value. Okay. Question number, this is there. Now let me take this question here as minus n minus 1 into cos n x into dx. This is the final value, but this is a similar integral which we started with. Now let me take this to left hand side. This will be added, then again n minus 1 plus 1 n only will be there, and by dividing n we will obtain this. Okay, so let me remove this. Further let me proceed it. Taking this side, this is the first integral. Let me take this is I here, and I we started with. Here it will be 1 plus n minus 1 into I equal to this value. Sorry, this is sin x. Okay, therefore sin x, this is into cos of n minus 1 x plus n minus 1 into cos of n minus 2x into dx. Now dividing by this is minus 2 plus 1, n will get here. Therefore, sin of integration cos of n into x into dx equal to sin x into cos n minus 1 into x divided by n plus it will be n minus 1 upon n sin of integration cos of n minus 2 into x into here. This is a reduction formula. This is a reduction formula for cos of nx, cos power nx, and this is reduction formula for sin power nx. Reduction formula for sin raised power nx. This is, well, let me write it here. With the two formulae, let me write here, and then proceed for other functions. And finally, we have obtained this reduction formula for cos, and this is first, this is second. Cos of nx into dx. Here it is positive sin x into cos of n minus 1x upon n plus n minus 1 upon n sin of integration. This is cos of n minus 2 into x into dx. Okay, so this is the second formula. First and second, these are the two formulae for sin x and cos x. So question number 1 and 2, they are solved here. These are the reduction formulae for cos and sin and cos again. Now they are used successfully for calculating other integrals. Now let me talk about here. What is the question number 3 now? These two formulae we are discussed in question number 1 and question number 2. They are done. Now let me talk about third question. So the question number 3. Question number 3 here, sin of integration. This is sin raised power 6x into dx. Now if I substitute reducing for this n minus 2, 4, 2 only. If I substitute n equal to 4 and 2 and reduce the formula. Let me first find out cos 6x will be what? By using reduction formula. Using a reduction formula for sine nx dx, we get for the sine 6 over here integration of sine 6x into dx and taking n equal to small n equal to 6 is first we will use 6, then one less than this one here it will be 5 over, but others will be 2 and 2, n equal to 4, 2, then 0, 0. Okay. We get here taking n equal to 4, we get, so we get written down here. Therefore this will be how much? Minus sine, it will be cos x, but divided by 6 only. 6, and with that 6, 4, 2 for n. So plus that will be first is cos x into sine the power 1 less, so 5x divided by 6 here. Okay, with plus sine n minus 1, that means 5 upon 6. N minus 1 upon n, and here is 6. Okay, then sine of integration. It will be now sine the power 4x into dx, because n minus 2 power, sorry this one, n minus 2 and n minus 1, that means 6 minus 1, 5.6. This is the first, let me take the first part, first equation. Then R to integrate this, and sine of integration and sine 4 x into dx equal to minus cos x sine the power 3x divided by 4 plus sine, so with 3 upon 4, 1 less than this, n minus 2. Sine of integration, here it will be sine square x. Further to this is second equation. Now sine square x is to be integrated. And finally, let me add here, comma, and sine square x into dx is equal to minus cos x into sine x on